or millennia, humanity has looked up at the stars and wondered, are we alone in the universe? This question has driven us to build telescopes, launch probes, and listen for signals from the cosmos. The search for extraterrestrial life is really a search to understand our own place in the universe. We now know the ingredients for life, carbon, hydrogen, oxygen, are scattered throughout the galaxy. With billions of stars and planets, it seems unlikely Earth is unique. Among the thousands of exoplanets discovered, one stands out, Proxima B, orbiting the closest star to our Sun. Its discovery in 2016 electrified scientists and the public alike, offering a real target in our search for life. The story of Proxima B is a story of hope, challenge, and the relentless human drive to explore. Proxima Centauri, our Sun's nearest stellar neighbor, is a dim red dwarf just over 4 light-years away. In 2016, astronomers discovered Proxima B orbiting this star, a rocky planet at least 1.3 times the mass of Earth. Using the radial velocity method, scientists detected the planet by observing the star's subtle wobble. Proxima B's proximity makes it unique. It's close enough for our telescopes to study in detail. Unlike distant gas giants, this world is a prime candidate for habitability. For the first time, we can point to a specific star and say, there might be another Earth-like world right there. Proxima B has transformed the search for life from an abstract idea into a concrete mission. It's become a focal point for our dreams of interstellar exploration. The possibility of a nearby habitable planet has inspired a new era of scientific ambition. What makes a planet potentially habitable? Is it just about being the right distance from its star, or is there more to the story? It's all about the habitable zone, the region around a star where temperatures allow liquid water to exist. This so-called Goldilocks zone isn't too hot or too cold, but just right for water to remain in its liquid form, which is essential for life as we know it. Proxima B orbits within this Goldilocks zone of its cool, dim star Proxima Centauri. Unlike our Sun, Proxima Centauri is a red dwarf, much smaller and fainter, which means its habitable zone is much closer in. While it completes an orbit in just 11.2 Earth days, a year on Proxima B is less than 2 weeks for us, its position could allow for temperate conditions where water might pool on the surface given the right atmosphere. The presence of an Earth-mass planet in the habitable zone is the first step in the search for life. It's a rare and exciting find because it means there's a world out there that could, in theory, support biology similar to our own. Without liquid water, life as we know it can't exist. Water is the universal solvent, the medium in which the chemistry of life unfolds. Its presence is a fundamental requirement for any living system we can imagine. The fact that such a world exists around our nearest star feels like cosmic luck. It's a reminder that the universe may be more hospitable than we once thought, and that the conditions for life might not be unique to Earth. But being in the habitable zone is only the beginning. There are many more factors that determine whether a planet is truly habitable, from its atmosphere to its magnetic field and geological activity. We still don't know if Proxima B has an atmosphere or the right chemistry for life. Its proximity to its star means it could be bombarded by stellar flares which might strip away any protective gases. The Goldilocks zone offers potential, but the reality could be far more complex. Habitability depends on a delicate balance of many factors, and each discovery brings new questions. Proxima B's position is a tantalizing clue, but it's just the start of a deeper investigation. The search for life continues, as we look for more signs that this distant world could truly be another Earth. Water is the key to life as we know it. On Earth, wherever there's liquid water, there's life, even in the most extreme environments. That's why astronomers always follow the water when searching for habitable worlds. Proxima B's location in the habitable zone means it could, in theory, have liquid water, if it has the right atmosphere. This possibility fuels our imagination. Oceans under a red sun, rivers winding across an alien landscape. The laws of physics and chemistry are universal. If Earth-like conditions exist elsewhere, life could too. But so far, water on Proxima B is only hypothetical. Detecting it from over 4 light-years away is a huge challenge. Future telescopes will search for water's spectral signature in the planet's atmosphere. Finding it would be a watershed moment, showing that Earth is not unique in its life-giving conditions. Proxima B's close orbit around its red dwarf star likely means it's tidally locked, a phenomenon where the same side of the planet always faces its sun, much like how the moon always shows one face to Earth. This unique orbital dance has profound consequences for the planet's environment and any potential life that might exist there. On Proxima B, one hemisphere is bathed in relentless, unending sunlight, scorched by the star's rays day after day. Meanwhile, the opposite side is plunged into eternal night, locked in a deep freeze with temperatures dropping far below anything found on Earth. This creates a world of extremes, a scorching, sun-baked dayside where temperatures could soar to inhospitable levels, and a frozen nightside where ice and darkness reign supreme. The only region where life might stand a chance is the narrow twilight band between these two zones, a thin, perpetual dusk known as the Terminator line, where temperatures could be more moderate and stable. If Proxima B possesses a thick, insulating atmosphere, it could help distribute heat from the day side to the night side, potentially making larger areas of the planet habitable and softening the harsh contrast between day and night. However, whether Proxima B actually has such an atmosphere remains one of the most crucial and intriguing unanswered questions in exoplanet science. Life on a tidally locked world would be very different from anything we know on Earth. Plants and animals would need to adapt to constant twilight, evolving unique strategies to survive in the dim, unchanging light. The challenges for life are immense: extreme temperatures, limited energy, and possibly fierce winds between the hot and cold sides. Yet life is remarkably resilient, and could find a way even in these harsh, alien conditions, perhaps thriving in ways we can scarcely imagine. The very concept of Proxima B forces us to expand our imagination about where and how life might thrive in the universe. Proxima B's dramatic extremes make it both a fascinating and daunting target in the ongoing search for life beyond our solar system. Proxima Centauri is a volatile red dwarf, unleashing powerful stellar flares. Proxima B, orbiting so close, is bombarded by intense radiation. These flares could strip away the planet's atmosphere, leaving the surface exposed and lifeless. A strong magnetic field could help protect the planet, but tidally locked worlds may not generate one. The survival of Proxima B's atmosphere is uncertain, and without it, life is unlikely. Scientists use computer models to study these effects, and the outlook is challenging. The excitement over Proxima B is tempered by these harsh realities. It's a case study in the delicate balance required for a planet to be truly habitable. How do we study a planet trillions of kilometers away? With powerful telescopes like the James Webb Space Telescope, JWST uses transit spectroscopy, analyzing starlight that passes through a planet's atmosphere, to search for chemical fingerprints. Scientists look for gases like water vapor, methane, carbon dioxide, and especially oxygen. The presence of both oxygen and methane would be a strong hint of life, as these gases tend to destroy each other unless something is replenishing them. Observing Proxima B is difficult. The planet is small, and its star is active. It will take many hours of careful observation to tease out any signals. Modern space science is a slow, painstaking process, not a single eureka moment. But JWST gives us our best chance yet to learn what Proxima B is really like. Proxima B embodies the spirit of exploration, promise, challenge, and hope. It stands as a symbol of humanity's relentless drive to reach beyond the familiar, to ask questions that have never been answered, and to dream of worlds that may one day be within our grasp. The discovery of Proxima B has ignited imaginations across the globe, inspiring scientists, dreamers, and explorers alike to look up and wonder what lies beyond our own blue planet. As of now, no life has been confirmed there. Claims to the contrary are misinterpretations. The surface of Proxima B remains a mystery, an empty canvas waiting for us to uncover its secrets. While some headlines may exaggerate, the truth is that we are only at the very beginning of understanding what this distant world is truly like. Scientists like Michio Kaku highlight Proxima B as a prime candidate, not as proof of life. Their excitement is rooted in the possibility, not certainty, that this planet could harbor the right conditions for life as we know it. The scientific process is slow and careful, requiring patience and rigor as we sift through data and refine our understanding. What matters is that we now have a real target for our search. For the first time, we can focus our instruments and our hopes on a specific world orbiting a nearby star, rather than just imagining what might be out there. This focus brings a new sense of purpose and direction to our quest. The questions we ask about atmosphere, water, and chemistry will teach us about planets everywhere. Each answer we find, even if it's not what we expect, adds to our knowledge of the universe. By studying Proxima B, we learn not just about one planet, but about the countless worlds that fill our galaxy. With new telescopes coming online, our ability to study worlds like Proxima B will only improve. Advanced technology will allow us to peer deeper into space, analyze distant atmospheres, and perhaps even detect signs of life where none were visible before. The next generation of observatories will open doors we can only imagine today. Even if Proxima B is lifeless, the search continues. There are billions of other planets to explore. Each discovery, whether it reveals a barren rock or a thriving ecosystem, brings us closer to understanding the diversity and wonder of the cosmos. The universe is vast, and every new world is a chapter in the story of exploration. The quest is about more than finding life. It's about understanding ourselves and our place in the cosmos. As we search the stars, we reflect on our own origins, our shared hopes, and the future we wish to build. The journey outward is also a journey inward, connecting us to each other and to the universe itself. The journey to Proxima B is part of our collective story, a testament to human curiosity and optimism. It reminds us that exploration is a fundamental part of who we are, and that every step we take into the unknown is a step toward a brighter, more connected future. The universe is full of possibilities, and our search has only just begun. With every new discovery, we expand the boundaries of what we know and what we can imagine. The adventure is far from over. The next chapter awaits, just beyond the stars.